Okay, let's do this question. We have a drop from O to the tangent. So let me draw the tangent. This is the tangent. We have a drop from O to the point of tangency. And then this O also hits the point, say, A. So from A we have a chord hitting the point, say B. Now we have to find the arc length APB. This is required. So how are we going to do that? Now, by alternate segment theorem, let this chord make an angle of alpha with the tangent CD. Let AB make an angle of alpha with CD. CD is the tangent. So by alternating segment theorem, this is equal to 2 times alpha here, angle at the center. Okay, this means angle at O is 2 times alpha. Now by tangent radii theorem, this OB will make an angle of 90 degree. Angle at B is equal to 90 degrees. So this means, so this angle is 90, so this is going to be 90 minus alpha. Now this is an isosceles, so this will also be 90 minus alpha. So if I were to take the sum of the angles in a triangle, I'm using this part of the space. So we have 90 minus alpha plus 90 minus alpha plus 2 alpha, which is all going to be equal to 180 degrees. Now the labeling is consistent. We are given 2 data points or 2 informations to handle this question. So one is alpha is given to be as 60 degrees and the radius is given by 12 units. So this arc is required, the arc length. Now arc length has got a formula, 2 pi, okay, multiplied with the radius, which is 12 units, times the angle, so 2 alpha, right? So that means we have alpha to be equal to 60 degrees. So 2 times alpha means it is going to be 120 degrees. So 120 over 360 degrees. So this is the formula we will have to use. So clearly 0 gets cancelled, and 3 divides here 4 times, 3 divides here 12 times, 12 and 12 gets cancelled. 4 times 2 pi is 8 pi. I will just say units, right? So what is this? This is the arc length APB. We got to enclose it within modulus sun. So this is the solution for this question, and it is imperative that you mention units. So that is the end of this question. Please we move on to the next.